Today, we're going to dive into some really fascinating new research. It's all about teaching an AI not just to be a tool for scientists, but to actually think like one. This is the story of how we might build a true AI co-scientist.
And this really gets to the heart of the matter. We've all seen AI do incredible things, like AlphaFold solving the protein folding problem. That's amazing. But that's solving a puzzle that we've already defined. The real question is, can an AI go a step further? Can it design the experiment in the first place? Can it come up with the research plan for a totally new discovery? That is a whole different ballgame.
This slide just lays it out so perfectly. Right now, AI for science is like an expert puzzle solver. You give it the rules, you give it the pieces, and it's brilliant. But the next frontier, that's about inventing a whole new game. It's the difference between following a cookbook recipe and being a chef who creates that recipe from nothing. We're moving from a nice, controlled sandbox into the messy, unpredictable wild of real science.
And the researchers have a great name for this. They call it the sandbox problem. See, breakthroughs like AlphaFold were possible because the problem could be neatly contained and simulated in a sandbox. But for so much of science, especially in fields like medicine, you can't just simulate everything. The real world is messy. Trial and error can be incredibly expensive or even dangerous. So we need an AI that can handle that mess right from the start.
Okay, so this challenge forces a really fundamental shift in thinking. Instead of focusing on building an AI that's an expert solver, the goal becomes creating an AI that's an expert planner. So here's the big idea, the real light bulb moment. What if the most important part isn't just running the experiment, but designing it? What if you could teach an AI that creative, strategic process? How to form a hypothesis, how to design the right controls, and how to map out a clear path to a potential discovery. And, the paper itself just says it perfectly. This is where the real brain power is needed. Getting the plan right. That's everything. A bad plan wastes time, money, and effort. But a brilliant plan, that can unlock a whole new field of science. So this is what the researchers decided to focus their AI on. All right, so how on earth do you teach an AI the art of scientific planning? It's not like you can just hand it a textbook, right? Well, they had to build a custom curriculum, and how they did it is pretty wild. This is where it gets really clever. Instead of having humans painstakingly create thousands of training examples, they got other AIs to do the work. Just imagine a team of expert AI tutors creating a personalized curriculum for one student AI, all designed to teach it the art of research design. Okay, so let's break this down because it's a fascinating assembly line. First up, one AI reads a scientific paper and pulls out the key aha moment. Then, it turns that insight into a research goal and, this is crucial, it also creates a super detailed grading rubric. After that, another AI gets to cheat a little. It looks at the original paper and writes the perfect answer key research plan. And for the grand finale, a third selector AI acts as quality control, picking only the absolute best examples to go into the student's curriculum.
So, you've got the curriculum. Now the real learning can start. And this isn't your typical one-way street. It's a feedback loop where the AI student just keeps getting better and better by getting constant feedback on its work.
So, it all kicks off like this. The student AI is given one of those research goals from its new curriculum, and it just gives it its best shot. It comes up with a research plan. Then this other AI, the grader AI, steps in. Think of it like a tough but fair professor. It takes that plan and scores it against that super detailed rubric we just talked about, grading everything from the logic to the methods. And here's the key. Based on that grade, the student AI just goes back to the drawing board and tries again and again and again. Each time, it's tweaking its approach, learning from its mistakes, all in the pursuit of a better score. This whole setup has a name. It's called a self-rewarding loop. And it's a really elegant idea when you think about it. The AI is literally learning by grading its own homework. It has the rubric. It knows what a good answer looks like, and its only goal is to get better at hitting those marks. It's a really powerful way to learn a complex creative skill. Okay, so that's the theory. That's the setup. But the million-dollar question is, did it actually work? Let's dive into the results and see what happened when they put this newly trained AI planner to the test. And boom! This chart tells a pretty clear story. The red line is the base model, before all this special training. The green line is their model after training. You can see it got better across the board, but look at the top left, well-justified rationale.
That huge jump is so important. It shows the AI didn't just learn what to do, it learned how to explain why it should be done, which is a core part of real science.
But wait, it gets even better. Here, they threw it a curveball. They tested it on a completely different set of problems from specialized medical research. And look at that green line. The performance boost is even bigger. This shows us it didn't just memorize a few tricks, it actually learned a more general, adaptable skill of scientific planning.
Let's just boil this down to the raw numbers. The base model, right out of the box, was satisfying about 26% of the quality criteria. Their trained model jumped up to over 31%. Now, it's not at the level of the absolute top performer yet, but that's not the point. The key insight here is that the training method itself is a huge success. It works.
So what's the bottom line? It's simple. The method works. They successfully taught an AI how to think more like a scientist and design better, more rigorous research plans. It's a powerful proof of concept and a massive step forward.
And this brings us to the really big picture stuff, to the future. What is all of this building towards? Well, it's building towards the true AI co-scientist.
Look, the researchers are really clear about this. The end goal isn't just to make an AI that's good at planning experiments in one little corner of science. The real ambition is to create a generalist AI, one that understands the scientific method so deeply that it can apply that knowledge to biology, then to physics, then to economics, and beyond. And this quote from the paper, man, it just gives you chills, right? An AI co-scientist might be able to see connections that no single human ever could. Imagine it connecting an idea from a paper on marine biology to a problem in material science. That's a unique and powerful capability.
And that leaves us with this one big, exciting question. We are moving past the era of AI as just a tool and into the era of AI as a genuine collaborator. This research is a major step in that direction. So you've got to wonder, what incredible breakthrough is just around the corner, waiting for the right human researcher to team up with the right AI co-scientist?